All right, class, today we're looking at the last lesson in chapter 6, lesson 8, two-step inequality. So this is kind of like a culmination of all the things we've learned in this chapter in terms of solving equations, and then we turned it into solving inequalities. We did one-step equations and two-step equations. Then we did one-step inequalities, and now it's time for two-step inequalities. So just like before, we're going to solve them exactly the same. But we have to remember that one thing that we learned in the last lesson, which is when do we flip the inequality? When do we turn it over? When does greater than become less than? When does less than become greater than? So let's look at some examples. We're going to dive right in. If you've been doing well with these equations and inequalities, then this lesson, even though it's two steps and it's a little more difficult, will be hopefully not too bad. So let's go ahead and dive in. All right, so I've got 3x plus 4 is greater than or equal to 16. Okay, 3x plus 4 is greater than or equal to 16. Now, the first thing I want you guys to note is, look, there's no negatives involved in here, so you are not going to flip the inequality. I want you to be able to look at it and tell me, say right away what the answer, what will kind of look like, have an idea. And the way you can check is this. You look at the number, the coefficient, right, the number in front of the variable. If it's positive, which it is in this case, you don't have to worry about flipping inequalities. If it's negative, it's a negative fraction or a negative dividing number, then yes, you definitely do. Okay, but this one, all positive, so it's all good. Okay, so let's go ahead and let's solve it, right? First thing, we draw the wall. Next step, we say, okay, well, I want to get rid of the 3 and the 4. My x is my variable, so let's go ahead and subtract 4 on both sides. Draw a line and simplify here. 16 minus 4 is 12. And these cancel out. I'm left with 3x. And again, same sign, right? Greater than or equal to 12. Then our next step, we see that's 3 times x. So I want to divide by 3 on both sides. All right. So that becomes simply an x. 12 divided by 3 is 4. And again, we did not divide by a negative 3. We divided by a positive 3. So that's going to stay greater than or equal to. And that's it. That's how you solve these problems. Let's go ahead and graph it. Hopefully we're getting pretty good at this graphing by now, but let's take a look here. All right, so we say, okay, close dot because we have the equal to, closed, and greater than goes to the right. And that's how you solve these. And then, of course, you can check by checking any number to the right of 4. So 5, 6, 7, 8, 100, whatever it is. If you plug it in, it should work. So we'll check one here really quick. Let's just do a quick little check. Let's just take the next number here, positive 5. 5 is a solution. 5 should work. Let's see it. 3 times 5 plus 4 should be greater than or equal to 16. Let's try it. 3 times 5 is 15. Plus 4, is that greater than or equal to 16? Yes, it is. 19 is greater than 16, so we know we got it right. All right, let's do another one. All right, 5 plus 4n is less than 33. Okay, 5 plus 4n is less than 33. Let's go ahead and do it just like we've done all the other ones before. Draw a wall. Again, for the very beginning, I see that as a positive 4n right here. I'm not going to flip my inequality. I should know that right from the very beginning. Okay, so I know it's usually 4n plus 5, but remember, this is a positive 5. You can think of it as just positive 5. So how do I get rid of a positive 5? Again, subtract 5 on both sides. And I'm left with 4n is less than 28. Last step. Let's go ahead and divide by 7. Okay, so you should remember from when we did two-step equations that we do the adding, subtracting first, unless you have like the parentheses, right? Those are ones that kind of throw us off a little bit. This one we divide by 4 on both sides. Okay, and again, I use different, you could use division whichever way you want to do it. So if you want to do it with the fraction bar, you can, or the division sign, whichever makes sense to you. All right. These go ahead and cancel out. I'm left with n Again, I do not flip since I divided by a positive 4. So I don't flip. 28 divided by 4 is 7. Let's go ahead and graph it. Here it is. Here's 7. No equal to, so it's going to be an open dot. Less than, so it's going to go to the left. Okay. So that's how we do these problems. So let's make things a little bit more interesting now. Okay, let's make them a little bit more interesting. Throw in some minus signs and some negatives and see if we can figure it out. All right, here we go. Next problem. 7 minus 2m is greater than 11. Okay, so this is what's different right here. This one looks a little bit different than the ones before. Well, why? Okay, again, we see this. Remember, that minus belongs to it. So if you cover up that 7, it's a minus 2m, or remember, you can think of it as a negative 2m. So I know that I'm going to flip my inequality. From the very beginning, I know my inequality is going to need to be flipped over. Okay, so let's go ahead and go through the steps. Again, the first thing we want to get rid of is that 7. So I see that as a positive 7, so I'm going to subtract 7 on both sides. That cancels out here. That leaves me with a negative 2m. And that leaves me with a 11 minus 7, which is 4. Still greater than at this point. Everything is still greater than. Haven't flipped anything yet. Now we go into what we did yesterday's lesson, or the lesson before, 6.7, where you say, okay, well, this is negative 2 times m. So I'm going to divide by negative 2 on both sides. Cancel that. So again, divide. And again, notice I divided by a negative 2. So what does that mean? That cancels out. I'm left with just m on this side. Good. 4 divided by negative 2. Positive divided by negative is a negative 2. And again, I divided by not 2, but negative 2. So that means greater than has to become less than. Less than. Everyone see that? Okay. Greater than became less than, right? You got to flip the inequality. I'll write that down here. Okay. So we subtracted 7, then we divided by negative 2, and then we flipped. All right, so let's go ahead and graph it. Here's negative 2. No equal to, so it's going to be an open circle. Less than goes to the left. Left than. All right. So not too tricky, hopefully. Like everything else, it takes a little bit of practice just to recognize, when do we flip? That's a big question a lot of students ask us. It's we flip when we're dividing or multiplying by a negative number. But notice it had nothing to do with the adding subtracting step, always with the division or multiplication step. Okay, how about this one? 9 is greater than or equal to 6 minus 3x. Okay, now this is one we haven't really looked at, where the variable's on the right side. Now you could do it if you want. If it really bothers you, you could flip it over. You could flip everything and put all of the 6 plus minus 3x on the left side and 9 on the right side. You can make it all. You could do all that if you wanted to. What you have to be careful is just, again, make sure that the inequality is facing the correct way. So this side, the open mouth, I like to call it the open mouth side, is towards the 9. So if you wanted to flip it over entirely and do it like this instead, just keep the open mouth towards the 9. And you can do it like that. So if it really bothers you and you'd rather have all the variable on the left side every time, you're allowed to do that, just to make sure. A lot of times what I'll see students flip everything, but then they'll forget to flip the inequality and they'll leave it like this. This is a completely different problem. Now the open mouth side, the greater than, is to the 6 minus 3x, so that's not right. Okay. So if you want to flip it, go ahead. Just make sure that you do it all the way correctly. Okay. I'm going to not flip it. I'm going to show you what it would look like, do the work just on a regular problem. Okay. So you could do it like this. Either way, right? As long as you write it correctly. Okay, so here we go. Let's draw the wall here. Again, I see that I have a plus 6, so I'm going to subtract 6 on both sides. What do I get here? Cancels. I get a negative 3x, and this is 9 minus 6, which is positive 3. Okay, so far so good. Nothing to flip. All right. So now I know that I've got this negative 3x, so I'm going to divide by negative 3, okay? And what do we get there? All right, so again, that cancels out. I'm left with x on the right side. That's good. 3 divided by negative 3 is negative 1. Okay, now here's the part. Again, notice we divided by negative 3 here. Okay. All right. We divided by negative 3, and we divide by negative 3. That means the inequality greater than becomes less than equal to, and it flips over. Now, if this bothers you and you want to flip over on the other side, you could totally rewrite it the other way. You could say, well, I like the x over here. I like the negative 1 over here. In the middle, again, the open mouth is going towards the x. So you could do it like that. X is greater than or equal to negative 1. Either answer, they're the same. Again, you can tell they're the same. You might say, but Mr. Learning, they're facing different directions. They're the same when the open mouth is towards the same thing. This time, they're both going towards the x. If we were to graph this, here's negative 1. It's an equal to, so it's a closed dot. It's greater than, it's going to the right. Again, you have to make sure you read from the variable. A lot of people will say, well, Mr. Leung, the arrow is pointing to the left right here. So can I just go to the left? No, remember, we read from the variable. This is what's actually happening. So make sure that you graph that, right? And if you want, you can read this one backwards. That's a good strategy, is saying this is x is greater than negative 1. See that? So I like to say read from the variable. Okay. So these problems, this is a pretty difficult one because you both had to flip, right? So should write that in. We did need the flip on this one. And also the variable is on the other side, so it's kind of a little bit confusing, but I think it's something that you can, if you just kind of take your time on this, if you go too fast, then it's really easy to make mistakes on these problems. All right, last one we'll do, just one more example here. Y over 2 minus 5 is less than negative 8. Y divided by 2 minus 5 is less than negative 8. Okay. Here we go. I see I've got this y is over here over 2. We'll deal with that later. I have a minus 5, so I want to add 5 both sides. Cancels out here. I left y over 2 is less than, this is going to be negative 3. Okay. Now, again, remember, what we should have done in the beginning is notice, again, the 2 under the y is not negative, so we're not going to do any flipping. We should know that already. But if we didn't remember that, that's okay. Let's do it from this step. We see that's divided by 2, so I'm going to multiply by 2 over 1 on both sides. So I get those 2's to cancel. I'm left with y here. This is going to be negative 6. Oh, the answer is negative. Shouldn't I flip? No. Remember, I multiplied by a positive. Okay. I multiplied by a positive 2. So I do not flip. No flip on this one. Stays exactly like that. Y is less than negative 6. When I graph it, here's negative 6. Open circle, open dot, because there's no equal to. Less than goes to the left. So again, exactly like solving equations, the two-step equations that we did in lesson 6.5. The only difference is, again, with the inequalities, do I flip or do I not flip? And just like in lesson 6.7, You flip only when you multiply or divide by a negative number. In this case, you did not, so you do not flip, okay? Again, the step is right here. Multiply by 2, no flip. Divide by -3, yes flip. Divide by a -2, yes flip, okay? Divide by a +4, no flip, all right? So that's the idea that we get here. Again, you do your add and subtraction first, and then you do your multiply and divide. Okay? And that's two-step inequalities.